Welcome to the video showing you how to calculate molecular formula. Now, this is actually fairly simple, and the trickiest thing would be finding the empirical formula. But once you find the empirical formula, to then find the molecular formula, which is really the real formula for a compound, it's very simple. So there are 4 examples in your notes, and I'm just going to show you how to do all of them. Again, what I highly suggest you do is once you get the hang of this, you pause the video, try it yourself, and then watch the video and just make sure you're doing it correctly. Okay, and again, you can pause the video whenever you need to be able to solve the problem. So the first one, it tells you that the empirical formula was already calculated for you, and it was C2H5. Now, I can tell you that on any test and any exam, I will never ever give you the empirical formula. I will always have you calculate it for me, okay? Now, I also told you in the question that the real molar mass, or the actual real molar mass, was 58 grams per mole, okay? So the first thing we want to do is we want to figure out what is the molar mass of my empirical formula. So to do that, we have 2 carbons and 5 hydrogens. And that will end up giving you a molar mass of 29.07 grams per mole. Okay? The next step we're going to do is we are going to see how much more the actual compound weighs compared to our empirical formula. So to do that, we're going to take the molar mass of the real formula and we're going to divide it by the molar mass of the empirical formula. So we're going to take 58 divided by 29.07. And when we do that, we're going to get approximately 2. Now I can tell you right now that this number right here has to be a nice, what I'll call clean number. Okay? You could get, for this example, if you got 1.9, you could live with it. 2.1, you can live with it. But if you tried this calculation and you get a number like 2.4, that is not clean enough. Because when you round that, you're going to go, oh crap, do I round that to 2? Do I round it to 2.5? And it should be very obvious what you're rounding it to, okay? If you did an experiment, then you might get a number like that, and then that's strictly because of experimental error. But on an assignment, on a test, on an exam, you should always get a number that's going to be incredibly close to a whole number. Now, in this case, this number tells me that the real formula is double the weight of the empirical formula. So if I want to know the molecular formula, I'm going to take my empirical formula and I'm basically going to multiply those subscripts by 2. So my molecular formula will actually be C4H10. And that would be the real one. So that's how you do that one. It's very, very simple. In the second example, we're going to do this exact same thing. So in this one here, I'm giving you that the empirical formula is CHO2. And we know that the molar mass of the real formula was 90 grams per mole. Now keep in mind, I have to give you that, okay? We're going to find the molar mass of my empirical formula. It's going to have 1 carbon, 1 hydrogen, and 2 oxygens. So when I do that, I am going to end up with a molar mass of 45 grams per mole. I'm going to take the molar mass, the actual one, divide it by the molar mass of my empirical formula, 90 divided by 45, and again, I end up with a nice clean number of 2. So that means my real formula is double my empirical formula. So my molecular formula, I'm going to take that ratio of 1 carbon, 1 hydrogen, 2 oxygens, double it. So it's going to be C2H2O4. And that's how you do that one. The last, oh no, second last one, sorry. Number 3, I give you the empirical formula of codeine, C18H21NO3. That's a monster, okay? And I give you the actual, so you can write actual or real, obviously they mean the same thing. This is 299 grams per mole. So what I want to do here is I want to find the molar mass of the actual compound, or sorry, of the empirical formula. So we got 18 carbons, 21 hydrogens, 1 nitrogen, and 3 oxygens. Okay? You would actually, obviously look those up on the periodic table. I'm going to save you a little bit of work right now. And when I do this, I end up with 299.4 grams per mole. Okay? So when I do that, I'm going to take the real molar mass divided by the molar mass of my empirical formula. 299 divided by 299.4, and I get really close to 1. So that's basically just telling me that the empirical formula, molar mass, and the actual one are the same, so it must be the same compound. So my molecular formula is going to be CH18H21NO3, and that's how you would do that one. The final example, this is one that you will see on a typical test and on a typical exam, because this kills 2 birds with 1 stone, okay? So in this one here, I do not give you the empirical formula. You have to actually calculate it. So this is where you have to know your table, and this compound is made up of carbon, it's made up of hydrogen, and it's made up of oxygen. In this column, I'm putting down my givens, and masses weren't given, but percent compositions were given. So the mass of carbon is 75 grams. The molar mass of carbon is 12.0 grams per mole. The percent for hydrogen is 5. The molar mass for hydrogen is 1. And then for oxygen, I have a percentage of 20, so that's 20 grams, and my molar mass is 16.0 grams per mole. So I'm done that column. My next column, I'm going to find the number of moles. Mass divided by molar mass. So I am going to do 75 divided by 12, which when I do that, I'm going to get 6.25 moles. I'm going to do 5 divided by 1, which is going to give me 5 moles. And then on the last one, 20 divided by 16. And when I do that, I get 1.25 moles. So this is the smallest out of all of them. So in my final column, I'm going to divide by 1.25, which is my smallest one. So I can do that right here. 1.25 divided by 1.25. That's simple. That's 1. 5 divided by 1.25, and that's going to be 4. And then if I get 6.25 divided by 1.25, I get 5. So that means my empirical formula is C5H4 All right. Now, the molar mass of the actual compound is given to you in the question, and that was 240.28 grams per mole. I want to find the molar mass of this. So you have 5 carbons, 4 hydrogens, and 1 oxygen. And when I do that, I end up with 80 grams per mole. I'm going to take my 240.28 divided by the molar mass of my empirical formula. And when I do that, I get about 3. Again, when you actually punch it in your calculator, you're going to find that it's very, very close to 3. So that means that my molecular formula, I have to multiply all of my ratios by 3. So it's going to be C15, H12, O3. And that's quite a monster of a compound. Okay? And that's how you solve molecular formulas. So good luck with all the questions that you're going to be assigned. Take care.